Hi guys, today we're going to be doing the dry ice lab, and our question is going to be, does dry ice melt the way regular ice does? Our hypothesis is that dry ice melts differently than regular ice. The material we're going to need is ice, dry ice, and a brown paper towel. The procedure is going to be place a piece of dry ice and a piece of regular ice on a brown paper towel. However, we're going to use a white towel today.
Okay, so at this point right now, this ice over here seems to be melting faster and it's more glossy and shiny. While over here, this ice is smaller and it's very dull.
Dry ice, the color is really opaque. It is white and you can actually see gas coming off of it. And it looks like opaque and dry. This is the regular ice. It looks like clear, crystal transparent, and it looks like it's melting really fast, and there's a lot of water coming out. So based on our observation, regular ice and dry ice melt differently. So regular ice goes through the process of melting, and dry ice goes through the process of sublimation.
Now we're going to move on to our second lab, which is what happens when dry ice is placed in water, and our hypothesis is that it will sublimate even faster. And our materials we're going to need is one piece of dry ice, one paper cup, some water, and some dish detergent. So now here I have my piece of dry ice, and I'm going to place this inside my cup that's filled with water and some soap detergent. And as you guys can see, bubbles are forming rapidly. The dry ice is reacting very explosively. Now, as you guys can see, there's a dome of bubble forming on top. And it's still rapidly exploding. Stop.
As you can see now, the bubbles are expanding, and it seems like all the bubbles are go out the cup.
So now the bubbles have calmed down, but the dry ice is nowhere to be found yet.
So now it's been around 2 minutes and the bubbles have really calmed down. The dry ice already supplements in the water, and it took only 2 minutes. So I think that if you put the dry ice in even hotter water, it will supplement even faster.
Continue with our lab 3, and the question is, how can we make dry ice supplement faster? Our hypothesis is dry ice supplement faster in hot water, and the material we need is 2 pieces of dry ice, 2 styrofoam cups, 1/4 cup of cold water, 1/4 cup of hot water, about 50 degrees Celsius. And our procedure is place a piece of dry ice in 1/4 cup of cold water and another piece in 1/4 cup of hot water.
Now I'm going to put the dry ice into a cup of cold water and hot water. So you see the hot water is reacting very rapidly.
So this is the hot water and this is the cold water. The hot water is producing a lot more gases.
You can also hear the sound of bubbles, right?
The hot water is already forming a mini fog around it.
Cold water.
However, the cold water is still producing some gas, but it's not as rapidly and violently as the hot water.
After like about 1 minute, you can see that the fog in both cups have calmed down and there isn't a lot of fog left.
However, the one in the cold is nearly gone and the hot is still going on. This is a close-up of the fog that's producing in the hot water.
Right now on the cold cup, the ice seems to still be bubbling around. And on the hot cup, the ice still producing a lot of fog.
The overall conclusion of all three labs is that dry ice melts differently than regular ice. Dry ice reacts rapidly when placed in water. It produces a very foamy fog. And to make dry ice supplement faster, all you have to do is place it in hot water. Because as you guys can see from our third lab, this is the dry ice from the hot water, and it's super tiny. However, from the cold water, there's still a good chunk left.
I hope you enjoyed our science lab report video.